Hello, I'm Mark Janikis. This is Carlos Osorio Murillo, and we're partners on the Spatial Statistics team. We're developers, and we're going to talk to you today about extending ArcGIS Pro with .NET and Python, with the whole basis of trying to get interactive analytics for you to do your particular type of analysis. So ArcGIS Pro is highly customizable, but back in desktop, really ArcObjects in Python, we're using conjunction to do this. There were some Python add-ins, but basically ArcObjects were used to extend the application. The story for Pro is that Python is still the engine, it's still the GP engine, it's still how you drive analytics. But if you want to extend the application, both through GUI widgets or through interactivity, that you use .NET and C# to go ahead and do that. And we realize here at Esri that there is so many fantastic projects and analytics being done in your specific fields of expertise. It would be impossible for us to create all the different interactive data types, all the different types of workflows that make you special and you unique to what you do. So it's important for us to provide an avenue for you to extend ArcGIS to serve your customers or serve your academics or your work in general. So what's the objective here? Again, is to integrate .NET and Python to improve your workflows. We're going to give you an example where we're going to add something to an existing entity. Our entity is a Spacetime Cube. We'll talk more about that, but we want to make an origin destination cube for reasons that we'll bring up. And we're going to quickly demonstrate how we did it and how that application is created in Visual Studio. How many people have created .NET add-ins for ArcGIS Pro? A few of you? Great. So for those of you who haven't, don't worry if some of this stuff seems advanced. It is a pretty advanced analytic that we're working with. Some of the concepts, obviously, you'll get. But if you feel like we're moving too fast through some of the code, don't worry. All the code, both the basic how-to and the actual how-to for this demonstration is provided in GitHub repos, and we'll give you the websites for those. So don't worry if you miss something. It'll all be there, and you can go ahead and use it as a template and then maybe replace a few things to make it work specifically for you. So what is a Spacetime Cube? This came out, I think, 4 releases ago. Our Spacetime Cube is initially was the ability to take spacetime points, a lot of spacetime point patterns, and aggregate them into these spacetime cubes. They're a fixed set of gridded locations, either hexagon or fishnet bins that have a temporal component. So the spacetime points get aggregated into the spacetime rasters, if you will, or grids, if you will, and then the analytics are done on that. And this allows you to do a lot of high velocity analytics on very large data or relatively large data. Others use geoanalytics to even take it into the billions and billions. At any rate, so the Spacetime Cube will take points, aggregate them into spacetime cells, and then the analytics are done on those cells. We also have a defined locations cube, which the same analytics can be done when you have an irregular spatial pattern. That's either polygons or maybe rain gauges, like irregular points scattered out, but you have data at specific time periods. You can aggregate them into fixed or defined locations cubes as well. So that's what a Spacetime Cube is, but since probably a couple releases ago, we keep getting requests to be able to analyze tracking data. Data where we want to analyze maybe the covariation of movements between a couple agents in the cube, or maybe where things started and where things ended up, or the path of where they started on their way to where they ended up. So there are lots of different ideas and requests for us to extend the Spacetime Cube to do sort of tracking analysis. And this is a demo that will show you how we sort of did that workaround and how we actually got it working. And perhaps we'll see something a little bit more concrete in the releases to come. So in essence, it's just like a regular Spacetime Cube, but you're actually assigning IDs to the points. The points have IDs, and then they get tracked based on the bin that they're in. And you can have origins and destinations in the same cube, and then you can also have origins and destinations in two separate cubes and be able to analyze where they started and where they ended up based on their unique ID inside the cells. So that solution is essentially just a link. It's just a link that's saying every point has a unique ID and it knows where it started and where it ended up. And that's how we modeled it. A Spacetime Cube that just allows you to have an extra ID component, origins, destinations, and the links between the two. So NetCDF is the basis for the Spacetime Cube. NetCDF 4 in particular is based on HDF5. It's very efficient. Another nice thing about the NetCDF 4 HDF5 version is that you can have ragged arrays. And that means that you could have this one-to-many idea where each cell in the Spacetime Cube has an ID. It's time period 2, location 15 is how many rows and columns to get to 15. You have a unique ID for that cell. And that cell contains a bunch of origins. It may actually contain some destinations. In NetCDF 4 HDF5, you can actually have these ragged arrays where you can have one link cell ID to many origins or many destinations, right? So you can store these ragged arrays. So this is just a description of some of the additional attributes that were added to the NetCDF Cube in order to get to this OD concept. And what did we want to analyze? This was pretty interesting. We looked at taxi cabs in New York for a single day. And that was one day, and there was 432,000 records. And so we have a map of the origin points, and we have a map of the destination points, and your taxi ID could be your unique agent ID. So you know where you started and where you dropped off, right? And what we were kind of interested in the analytics was to see where were people getting picked up and where were they getting dropped off. Well, what about if they started at LaGuardia Airport, where would the spatial distribution of the destinations be based on the starting point being LaGuardia? And you could see this being applied to a lot of different type of analytics. So what's important here to note is obviously we have pickup and drop-offs. We also have a GP tool, and this GP tool was a way to create this space-time or origin destination cube. Right? So a lot of times you have the Python's doing the work. You can actually think of, before interactivity, if I made it a tool, if I had to have them fill stuff in, what would they have to do? So here we have a space-time cube that has this origin destination component. And what's nice about it is that you can still run the same core tools on this special space-time cube. Things like emerging hotspots, those are places where hotspots of pickups, origins, or destinations are growing or decreasing, where they're sporadic based on different points in time, where they're outliers of pickups and drop-offs. So we have a lot of tools that work out of the box for space-time cubes, and this new origin destination cube, the same analytics would work on that. But of course, we wanted to create something that was more specific to the OD type of space-time cube. So the first thing you do is you design a Python toolbox. So this is the first component when you're trying to create the Addin. You create a Python toolbox and design it that if it was a GP tool, what would the user have to put in to get the workflow done? In this case, if it were to be just a GP tool and we avoided the .NET overall, then we would have an origin layer and an origin cube and a destination layer and a destination cube. Many times you may want the same cube as the origins and destinations. They can be stored in both, and that way you have the sort of reciprocal nature that you may desire. But they don't have to be the exact same, just so long as the agents correspond. So the origin layer, again, is something that allows you to select where in that layer am I interested in focusing on, like LaGuardia. And then it allows you to highlight in the destination layer where those agents went during that time period, where the drop-offs were. So here's a Python tool that would allow you to then select the destination. This is what it looks like. This is just a quick look at the get parameter info information for it. And this just has the 4 parameters. Okay, and what does the execute look like? This, again, this looks familiar to anyone who's used a Python toolbox, just getting the parameters, doing the execution, using the core code that we provide that does the core analytics, and doing a few extra little things. So this is just the execute code, but it's important because the execute code can be called through the .NET application as well. So we want to integrate our Python toolbox into an add-in now. Now this is really important before we move on. If you've never created an add-in, this is a really important link. This link will walk you through a step-by-step process of creating an add-in using Visual Studio. By the time you get through this one, you should have a pretty good sense of how to get it done from start to finish, and then you just use that information or use that knowledge to expand. Okay, so if you haven't taken a picture and you need this, make sure you go ahead and do that. All right, and we can come back to this later if you need the link again. So I'm going to pass it over to Carlos now, and Carlos is going to walk through what our actual add-in does and show you the power of the add-in, and then he's going to walk you through how it was created.
Hi, everybody. Okay.
Carlos, switch to 3.
Switch to 2. Hi. I'm going to show what is going to be the objective of this add-in. We have a Spacetime Cube here. This is New York. And we have the origin of different places. For example, this is the LaGuardia Airport. We want to know for one location in time, here, for example, where is the people is going from this location. Okay, we call the add-in, that is going to be called show panel, and the add-in is going to say, okay, this is my layer. The NETCDF file of the cube is located here, the data, origin, NETCDF, and destination could be the same origin. The idea is that when we selected the location, the system is going to select all the places where it's going to try. Could be that it's not good here, but for here, for example, you see that locations is like a jumping with different colors. So, for example, if one taxi, the origin is here, in the middle of the Manhattan, the system is going to show where are all the taxis that are taken in that time in different locations in New York. Why that is important? Because with this information, we can analyze the behavior of different statistics. But for the information that you are analyzing, when you establish or create a map of layers, you want to know why. Why is that location is an outlier? Okay, you can examine all the places that you get the destination. Okay, this is the add-in. It's very simple, but we are going to show a demo of how the add-in is created. Okay, this is a simple Visual Studio project. Okay, you create the project, you put the name of the project, it's the same add-in that you already watched. Okay, we create the add-in. Okay, the first thing that we have here is the configuration demo. That file is the main file that is going to help us to go include the new classes that we are going to insert in the add-in. We put the name, the caption, that is the name that is displayed in the ribbon of the ArcGIS Pro. Then we add the new panel control. You see that we created a doc panel. That doc panel is added through the ArcGIS Pro add-ins. It's very simple. Create the panel. We put a new name in the doc panel. It's a panel OID. And then when you have the add-in, this is the class that is created, and we have two files or two new files. We have the panel OID, XML, and we have the view model. You know, the XML is the one that we are going to use for create the UI, Okay, here we are going to add the boxes, the combo box of each item that we are going to use. Here I'm going to show that. I'm going to add a little bit more. It's very simple. We know that this is the fast way, but when you are working in a real project, you don't want to use this approach. You have to. It's better to write the code to see you create the grid and the location, because in the case it's going to, you are not going to know where I'm going to locate the labels and the combo box. This is very simple to demonstrate how to create very easy the combo box or the user interface. Yeah, it's creating one. I'm going to jump to the other ones, and the other one is creating only the layout that we want to present. When you create the layouts, we need to also include how we are going to fit the layout. That is the moment that we have to use the view model in the Addin. Okay, the Addin. Okay, we finish here the button. When you finish the button, we have to go to the view model. And that view model is going to contain all the information that we are going to use, the variables that are going to be used to create the bindings with the UI. Okay, we have the different variables. We know that the list of layers that we are going to use. I'm going to put all the layers here. You see the list of layers are the one that we are going to use to populate the combo box. When we selected the layer, we create one variable to make the selection. We populate the other one. This is only the private variable that we are going to create. Then we change the name of the description of the heading to understand how it's going to look the dot panel. And we add the different properties of this class. Remember that the view model is the one that is going to load the data, and that data is going to be visualized in the UI. It's like the wrapper of the object that we are creating. Okay, there are the different properties. I'm not going to show you how to create it because it's very simple. One property, you have the get and the set. It's very simple for each one, but we need to create at the end another method. The other method is the one that, okay, for each one we are creating the different properties, but we need to introduce one method that helps us to add to get information on the current layers that we have in the view. This is the simple way to do it. We use what is the current view in the map. We then create the arrays of layers, and we go through the layers. Because we know what kind of layer we are going to accept, only point data. Okay, we filter only point data, and we have to verify that point data contain one field that the name is element. Why? Because in the cube, every bean is identified by that field, by one ID that is containing the field element. Of course, we have to read.
Okay, go ahead.
Okay, in the case when we create the method and we populate the layers that contain all the layers here. It's populating the variables. Okay, now we are going to create the execute. The execute is a wrapper execution function that is going to call the PYT that Mark talked before. that PYT, you only have to put the path. And there is a function that is very useful for combine the .NET Python that is called execute to async. That function that is execute to async is the function that we can put for run whatever toolbox that we have in the system. It's not only new tools. Whatever tool that is created in Pro can be run through this command. Okay? If you know that what is the syntaxis of that tool, you can use it directly in your tool, and it's very simple to do it, and that is going to improve your workflows really. Okay, that is the main function to search it. Then we need to indicate to the UI what is the variable that are going to take. Of course, the combo box, the first combo box is going to say, oh, the binding is the list of layers. Okay, we put the item source is the binding, layers origin, and the selection is going to be the variable that is selected layer origin. For each control, we have to put the bindings from the model view. You know, you are connecting the class that you created with the UI. This is a little bit different when we were working with Windows controls, because Windows control you can almost populate immediately in the C#, but in the WPF, the binding is the most essential part to have a very good workflow. Okay, when you finish to binding, the last one is going to be the button that is the execution. That changed a little bit because now you have to execute a command. Okay, you create a command and you say what is going to be the command that you created that you are going to execute. Remember the script that I showed you before in the view model? That is the one that is going to be executed here. Okay, when it's finishing this, we have to add one property to the drop-down. When you click the drop-down, the system has to make the trigger to populate the information. That is going to be in the combo box. That is a very simple way that you also making whatever UI interface is add new events in the process. Here, the only thing that we are going to do is put the code that is going to call the view model and the one that is going to load all the layers. You put here the name of the view model class. You have to change the names. When you change the names, you get the correct way. And now you compile. You say to start is like run the tool. The case is running like showing the demonstration that is working with the tool. You have the same demo that we already showed you. It's a very simple way you can visualize and select the different things using the cube. Okay? Okay, Mark.
Switch back for me. Okay, it's a lot. Can you turn yours off? It's a lot of information, but again, at the beginning, we provided the one link that shows you the basic add-in steps through Visual Studio. This link actually contains all the information for this demo, and it also includes all the information from the demo that we did last year on essentially an interactive reachability plot for density-based clustering. Once you've all taken a picture and have this link down, I'll go to the website now and I'll show you what it looks like on the GitHub repo. So go ahead and still waiting on, I think, one of you. Are we good? Okay. So what's that website look like? Here's the GitHub repo that has all the information. You can see interactive analytics. We have the one we talked about today. This interactive analytics was the one you did last year, right? And this is a screenshot of what the interactive reachability plot looks like. This actually has density-based clustering and it has a GUI popping up, and you can adjust the threshold to try to find the sensitivity for the clusters, and it'll do the change and show you where the clusters move, where the breaks change on the reachability plot. So that example is also there for you to go ahead and use and tweak to do something that you like. So if you like only a portion of it, maybe you can cut and paste some of that code and then apply it to whatever it is you like. And then again, we also have our example from today, which allows you to do interactive linking, if you will, with the two destination or origin destination cubes. So we are right at the end here. We have 5 minutes. Let me go ahead and start from current slide. We have 5 minutes to ask questions. Questions? No? No questions? You're gonna let us off easy? Something attacked me there. Okay. Oh, yes.
I'm just curious about what version of Pro. Is it in all versions, or?
Yeah, she asked what version of Pro that this is going to work on. Yeah, I would say 2.3, this one in particular, 2.3, and probably DB clustering was put in 2.2, right? Yeah, I think this one might, the cube one might work in 2.1. The cubes have been in there for a while, so really the constraint is the cube part, not the .NET part. But the clustering, the density-based clustering, the tool would have to be in the software, and that tool I think came in 2.2.
Can you do it for all versions?
Yeah, you should be able to do a .NET Python integration through all versions of ArcGIS Pro. I'm not sure of there being any sort of inability to do that, even in. If it's 2.0, I would assume 2.0 past would be fine. Does that answer your question well enough? Thanks. If you have any problems, take down my coordinates. You can always reach out to me. I can help you out. Any other questions today? They have a slide on here about rating the session, I believe. So I think there's an online survey app that you guys can do at your leisure. We really appreciate your time today, and we hope you have a fantastic rest of your Dev Summit. Thank you.